Welcome to this section on modeling. In this section, we shall make use of a ResNet based model in coming up with a system which could differentiate between an input which is a benign cell and an input which is a malignant cell. Now suppose we have this input image right here. We would have this input image will be of shape batch size by 224 by 224 by 3 after resizing and normalizing. Then we have our ResNet backbone, which has been trained on ImageNet. But although the images in the ImageNet dataset aren't like this, that is, they are not medical images, they are mostly images of objects like cars, cats, people, and other common objects. Nonetheless, our model does well even when pre-trained or even when we use this pre-trained ResNet backbone. Now after the ResNet backbone, the output tensor is of dimension of shape batch size by 7 by 7 by 2048. And then we apply global average pooling. We obtain this batch size by 2048. We have one dense layer with one output neuron, hence giving us a shape of batch size by 1. Now the reason why we have this 1 is because we are either predicting whether the input image is a benign cell or it's a malignant cell. So in that case, we have a binary classification task, hence our output is of shape batch size by 1. We now go ahead to replicate the model in the slides. We have this backbone, which is ResNet 50 trained on ImageNet dataset, input shape 222 by 222 by 3. Then we set this backbone to be untrainable. We now normalize, parse the backbone, global average pooling, and then the final dense layer for classifying whether the input image is a benign cell or a malignant cell. The model summary, there we go. We have close to 23 million parameters with only about 2,000 which are trainable.